In this video, I'm going to demonstrate how you can calculate a Pearson's R using R. Okay, well, the Pearson's R is a correlation coefficient that tests the relationship between two continuous variables, such as length of stay and the age of the patient. It shows us how they vary together. That is, does the length of stay go up as age goes up? And another example would be, does length of stay go down as activities of daily living goes up? That would be an inverse correlation. So as you recall, a correlation ranges from 0 to 1, or -1 to 0, and then to 1, a positive 1. The strength of a correlation is not measured by its sign, but rather how close it is to 1. So that actually a correlation of -0.7 would be stronger than a positive 0.5. That there would be a stronger relationship. What that means is that the two variables vary together. So, for example, again with age, as age goes up, does length of stay go up? In the case of ADL, we would expect a negative correlation, that as ADL goes up, length of stay goes down. So that would give us an inverse relationship or a negative value. Now, before you do a correlation, it's a good idea to do something called a scattergram or scatter plot. So the scattergram or scatter plot allows you to get a picture of what the relationship looks like, and it actually will put in the regression line. Let's go ahead and do that. But first, you need to install a package called CAR, C-A-R. So click on Packages, then click on Install, and let's type in CAR, C-A-R, and install. And let's see. Okay, now it's installed, so I'm going to go, here it is, right? So I'm going to load the package, CAR. Okay, and now I'm going to open up my Hospital One data set. Click on File, Open File, and it's on my desktop. So here it is, Hospital One R data, and I'll confirm it, yes, and I'm going to click on it, get my spreadsheet, and so now I'm going to use the scatter plot command in CAR and to get that picture. So scatter plot, then what I usually do is I put the variable that I want on the y-axis. In this case, I would want length of stay on the y-axis. So hospital, it makes it easier for me to interpret. Hospital 1, and then $, and let's look for length of stay, and then we're going to use that tilde, which is the shift and the key under the escape key, and then I'm going to put in my x-axis, which is going to be age in this case, which is measured in years, by the way. And let's look for age. Here we go. All right, and I'm going to put in two options. I'm going to type in smooth. Oops, I don't want those parentheses there. So I'm going to type in smooth equals F, and then I'm turning them off, and then box equals F. Okay, so that should be your command. Should look just like that. And enter. And it draws this nice little diagram. So we have LOS on the left side, and we have age, on the y-axis, and we have age on the x-axis. And we have our regression line. Now, the closer those dots, which represent a patient, are to the line, the better its prediction is. So the line represents what the model is would be predicting, right? So that's the predicted value, this line, right? And this is what we actually observe. So actually, when we do a correlation, it's a difference between these observed values and what we would expect. So the further away the dots are, the more error we have in our model. So the smaller the correlation, or the lower the value of the correlation will be, or the closer to zero it will be. Okay, so here we have it also, this shows us that it is linear, but we do have some outliers, and that's probably going to pull down our correlation. Okay, so that's an important assumption of correlation, is that it's a linear relationship. So it does seem to be linear, although it does seem like there are two, you could draw a line this way and that way. So anyway, there are some extreme outliers. Alrighty, let's go take a look at what the correlation tells us. So let's do that side pen options, and then we're going to do side pen, and I'll just use what it gives me here, equals 999, and I'll hit enter. And now I'm going to use the core.test function in R, and I want to put, it doesn't matter which variable you put first, but to make it consistent, I'll put length of stay first. And then a comma, and hospital 1, and $, and then we're going to do age. Okay, you can see here's the correlation coefficient. It's 0.249, which is kind of a weak association, although the correlation is statistically significant, so that we can reject an hypothesis that the correlation coefficient is equal to 0. So we can see there is some relationship, but you can see that there is those outliers that are probably pulling down that correlation. Okay, let's do another example. Let's take a look at length of stay and the TCATS mean variable. So I'm just going to bring back the scatterplot command here by pressing the up arrow, and I'm going to take out the $age. I'm going to put in $, and then I'm going to put in TCATS mean, and it flies out. Okay, so here you can see we have inverse relationship that as TCATS mean goes up, hospital length of stay goes down. So very it's kind of like what we'd expect. So now let's test and see what the correlation coefficient is. It should have a negative sign. So let's do that. Core.test command, and I'm going to put in hospital 1 and $, and again, it doesn't matter which one you put first, but I'll do, for consistency, length of stay, comma, hospital 1, $, T, CATS mean. So in this case, correlation is negative 0.529, which is a stronger relationship than we observed with the age variable. So it's a moderate kind of correlation, so that ADL does have some impact on length of stay. It would seem that it's associated to it, and we could see that the p-value here, testing whether or not the correlation is equal to 0, that there's no correlation between these two variables, can be rejected. Okay, go ahead and give this a try with some other variables you might be interested in. There's a variable in the data set called instrumental activities of daily living, TIDL mean. Why don't you run it, try that, and see if you get a similar correlation that we got with TCATS mean. That concludes the video.